Hello students, as I have promised you in previous video that we will learn about that why the concentration, why at different concentrations uh, the acid and in the case of a strong acid also common ion effect is applicable and how that we will learn. Okay. However, we have studied that common ion effect is applicable in case of weak electrolytes, but in a strong acid where the only one component is present, then also there is common ion effect. And how it is, let us see. See students, what happens in an acidic solution. There are two sources of H plus. Okay, and these sources are H2O and the acid. I am writing it as HA here. H2O give rise to H positive plus OH negative, which is a weak electrolyte. HA, which is a strong electrolyte, give rise to H positive plus K negative. Now, what happens here is, if the acid is not very dilute, like the concentration is 10 raised to minus 1 molar, 10 raised to minus 2 molar, 10 raised to minus 3 molar, 10 raised to minus 4 molar, 10 raised to minus 5 molar, or 10 raised to minus 6 molar. The source of acid, the source of H plus source, which is considerable, is acid only. That is acid only for all these concentrations. Now what happens at 10 raised to power minus 7 concentration of acid and at 10 raised to power minus 8 concentration of acid, the source of H plus is both acid and water. This lecture is going to be a bit lengthy. And for 10 raised to power minus 9 concentration or even less concentration or even lesser than that concentration, the source of H plus will be water only. Means the acid will produce negligible amount of H plus ions as compared to water. Hence, the concentration of acid is not considered here. The concentration of acid is not considered here. Here, the water produces negligible amount of H plus ions as compared to the acid. Hence, the concentration of water is not considered here. I am repeating again. In the solution of acid and water, here the concentration of H plus ions produced because of acid is very high as compared to concentration of H plus ions produced because of water. Hence, the concentration of H plus ions produced because of water are neglected here, and acid is the only source of H plus. However, both are producing the H plus ions. What happens in concentration less than 10 raised to minus 8 molar or 10 raised to minus 9, 10 raised to minus 10 molar is the concentration of H plus produced by water is very high as compared to concentration of H plus produced by an acid. So hence, here we will neglect the concentration of H plus ions produced by an acid and we will consider only the concentration of H plus ion produced due to water. Same thing will happen here. We will neglect the concentration of H plus ion produced due to water and we will consider only the H plus ions produced due to acid at a higher concentration like 10 raised to minus 1, 2, 3, 4, 5, 6. Now, let us understand common ion effect. We will take one example from the acidic solution also, like why the concentration, why the acid is only considered here. Okay, why not water is considered, and what will happen if we will consider the water. So now let us do this thing in the form of a question. Okay, so let us just write a question first. The question here is calculate concentration of H plus OH minus pH in 10 raised to power minus 6 molar solution. I am first calculating it for 10 raised to power minus 6. Then I will show you how can I calculate it for 10 raised to power minus 7. 10 raised to minus 6 molar HCl solution. Neglect H plus ions due to water. Considering H plus ions due to water. Case number 1, neglect H plus ion due to water. Case number 2, consider H plus ions due to water. And case number 3 is percentage error in both cases. Percentage error in both the cases you have to calculate. Now see, you had been given here H plus ions produced due to water you have to calculate. Okay, so let us do case number 1. If we will neglect the H plus ion due to water, then the concentration of H plus ion will be equal to 10 raised to power minus 6 molar only, because this is a strong acid. HCl give rise to H positive plus Cl negative. If initially HCl was 10 raised to minus 6 molar, then finally H plus ions and Cl negative ions will be equal to 10 raised to minus 6 molar, 10 raised to minus 6 molar, because this is 100% dissociated. So here the pH will be equal to 6. I hope you got it. That was simple. Now case number 2. What we are doing here is we are first calculating pH without common ion effect. Then we will calculate pH with common ion effect, and we will see the difference what we are getting. Now here HCl give rise to H positive plus Cl negative. Okay, same question we are solving, just by a different method you can see. H2O give rise to H positive plus OH negative. Not different method, or you can say a different way. Okay. Here we are considering the common ion effect. Here we have not considered common ion effect. Not considered common ion effect. Consider common ion effect. So the concentration of H plus ions produced here because of HCl and H2O. Okay. We are considering here. So let us say that concentration of HCl will produce 10 raised to minus 6 molar of HCl, H positive ions. Okay. And H2O definitely at room temperature will produce 10 raised to minus 7 molar H plus ions. Okay, let us say, because this is weak electrolyte, this will get shifted in backward direction. So let us say X amount of H plus ion is produced. So Kw is constant, which is 10 raised to minus 14. H plus ions concentration here will be equal to X plus 10 raised to minus 6. And OH minus concentration here will be equal to X. And the product of H plus and OH negative will be equal to X plus 10 raised to minus 6 into X is equal to 10 raised to minus 14, which is H plus into OH minus is equal to Kw. That is at room temperature is equal to 10 raised to minus 14. So let us solve it further. It can be written as 10 raised to minus 6x plus x square minus 10 raised to minus 14 is equal to 0. Now, for getting the value of x is equal to minus b plus minus root of b square minus 4ac divided by 2a. This will give us the value of x. Okay. Now, on solving, minus b means minus the 10 raised to minus 6. Okay. Plus minus root of b square means 10 raised to minus 12 minus 4ac. A means 1 and C means 10 raised to power minus 14 divided by 2A, that is 2 into 1. Okay, on solving this, what we finally get is the concentration of uh, OH negative ions for the X is equal to 0.01 into 10 raised to power minus 6, or this could be written as 10 raised to power minus 8. So we got here the concentration of OH negative is equal to 10 raised to power minus 8. The concentration of H plus ions is 10 raised to power minus 8 plus 10 raised to power minus 6, which is equal to 1.01 into 10 raised to power minus 6. Okay, this is the concentration of H plus ions. Now, for calculating the percentage error, if you will calculate the percentage error in the above problem, it will be equal to change upon initial multiplied by 100. What is the change here? That is 0.1, 0.01, because initially it was 10 raised to minus 6. From the first case, what is the answer you are getting? 10 raised to minus 6, and from the second case, you are getting 10 raised to minus 6 into 1.01. Hence, the change is 0.01. Initial was 10 raised to minus 6 into 100. And here you get 10 raised to power but 0.01 into 10 raised to power minus 6. Here you will get the error is equal to 1%. Percentage error, how much the percentage error you got here? That is 1% only. So 1% percentage error is the error which could be neglected here. The change will be equal to 0.01 into 10 raised to minus 6. That is 1.01 into 10 raised to minus 6 minus 10 raised to minus 6. So that is equal to 0.01 into 10 raised to minus 6 into 100. So percentage error is 1% here. And the percentage error is very low, that is even less than 5%. So it can be neglected. So percentage error is neglected and pH is considered here. So there is no need to apply the common ion effect when the concentration is 10 raised to power minus 6 or less than 10 raised to minus 6. You don't need to apply the common ion. So up to the concentration of 10 raised to minus 6, you don't need to apply the common ion effect, because the even if you will apply the common ion effect, you are going to get the same answer. Okay, so not considering common ion effect and considering common ion effect, in both the cases, we are getting the same pH, that is pH is equal to 6, and here also pH is equal to 6. So in the both cases, we are getting the same answer. Hence, we must not consider the common ion effect here. So up to 10 raised to minus 6 pH, you can do the question normal. I hope you understood this. For 10 raised to power minus 7 molar, we will do this in the next lecture. So let us end the video here. Okay. So I hope you enjoyed, and we will discuss about this more in next session. Thanks for watching the video. Happy learning.